Hello students. In this session, we will see the Pearson's correlation coefficient. This is also known as the Pearson's R. It is a statistical measure that calculates the strength and direction of linear relationship between two variables. It is widely used in various fields like finance, science, social science, and engineering to assess the how closely related two data sets are. The uses of the Pearson's correlation. The first one is determining the strength of the relationship. So in this, it tells how strongly two variables are associated. A value close to 1 or -1 indicate a strong correlation, while the value close to 0 indicate the little or no correlation. A positive value means that as one variable increases, the other tends to increase as well. A negative value of R means that as one variable increases, the other tends to decrease. The second use of the Pearson's correlation coefficient is in predictions. In a field like finance or economics, knowing how two variables are related can help in forecasting. For example, if there if there is a strong correlation between two stocks, you might use one to predict the behavior of other. The third use of the Pearson's correlation coefficient is in hypothesis testing. In hypothesis testing, the Pearson's R can be used to determine whether the observed correlation is statistically significant or not. In this way, the Pearson's correlation coefficient helps in identifying whether changes in one variable can be explained by the change in the another, making it useful for data analysis and research. Along with the some uses of this Pearson's correlation coefficient, it has the some limitations. So major limitation of the Pearson's correlation coefficient is it measures linear relationship only. The Pearson's correlation assumes that both variables are normally distributed and doesn't work well with outliers. So along with the theoretical background of the Pearson's correlation coefficient, we will see the mathematical intuition of the Pearson's correlation coefficient. How to find out the Pearson's correlation coefficient. So this formula is used for determination of the Pearson's correlation coefficient. The R is nothing but the Pearson's correlation coefficient. So this is determined. So R is equals to covariance of xy divided by standard deviation of x and standard deviation of y. So the covariance is calculated as here. So covariance is equals to summation of xi minus x bar into yi minus y bar, where the xi is the data point and x bar is the mean. So similarly, so yi is the data point and y bar is the mean, and n is the total number of data points. So by using this formula, we can calculate the Pearson's correlation coefficient. Along with this formula, so the other formulas are used here. So among other formulas, so this is the one formula. This is widely used for calculation of the Pearson's correlation coefficient. So R equal to n into summation of xy minus summation of x into summation of y divided by under root n into summation of x square minus summation of x square into n into summation of y square minus summation of y bracket square. So by using this formula also we can calculate the Pearson's correlation coefficient. Let's we see the one example on this. So this is the one example where you have to calculate the Pearson's correlation coefficient. You may calculate the Pearson's correlation coefficient as stated formulas, as by using the stated formulas. So in that first we will use the this formula and we calculate the Pearson's correlation coefficient, and we use this second formula also, and we can find out the Pearson's correlation coefficient. So these are the two different approaches for finding the Pearson's correlation coefficient, and these are widely used. So let's see, consider the one data set. X is given here. So the X data points are given as, so 15, 25, 35, 40, 50, 65 and 75. So similarly, the Y data points are given here. So 2, 5, 6, 8, 9, 10 and 14. Now you have to find out the, is there any correlation between the X and Y. So for that, first we use the this approach here. First we find out the values of the X, Y. So here the values of the X, Y are determined and their summation is also determined. So then we find out the X square and Y square. So that is required for the this formula. So this is the formula that we are going to use. So all of you have to find out the all these values by using the your calculator and formulate the one standard table and put the values of that in this formula. You will get the Pearson's correlation coefficient. Here this is the numerator value and this is the denominator value. So numerator value is nothing but the, so this one value here, okay, and denominator value is nothing but the, so this one value. So after that you will get these two values here, and finally so you will get the Pearson's correlation coefficient, so that r equal to 0.98. So we can use the this formula also. R is equals to covariance of the xy divided by standard deviation of x and standard deviation of y. Here we can find out the first covariance. So covariance is determined by using the this given formula. So summation of xi minus x bar into yi minus y bar divided by n. So here the summation of the xi minus x bar is determined here, and yi minus y bar is also determined. Here you can see. So this is the xi. Here just I change my pointer so that you can understand this in a better way. So this is the xi minus x bar value. This is the yi minus y bar value. So the multiplication of these two brackets, so that is a xi minus x bar into yi minus y bar is given here. Here we can see. So then after you have to find out the x minus x bar bracket square and y minus y bar bracket square to determine the standard deviation. So after that you will get the standard deviation for the x 19.1812 and standard deviation for the y 3.46297, and here the covariance that you will get 64.8633. Put all these values in the given formula so that you will get the Pearson's correlation coefficient. Hope all of you will calculate these values and make one standard table. You have to practice this by using your calculators. How to make the calculations by using your calculator is very important for examination. Thank you.